Hey everyone, welcome back to Rhythm Railroad. This is part 2 of my signaling video. I started my project basically yesterday. Basically what I did in part 1 was set up my Digitrax SE8C, powering it up and setting up the basic testing elements that come with it. So after I did all that, what I decided to do was go ahead and see if I could hook up one of my own signals, which I scratch built. This signal here was my first one that I scratch built. I'm pretty happy with it, and I'd like to install that in the layout soon while I build other signals. I did build this other one here prior to building that one, and this is just, I'm using it as a tester. Just to, in case something goes wrong, I'd rather it go wrong here than with one of those where I can't replace the LEDs or anything like that. This, if it gets ruined, it's worthless. That's why I made this. So what I'd like to do today is just walk you through this step. And again, just to reiterate what I said last time on part 1, I'm learning as I make these videos, so hopefully it'll be helpful for people that are also in the initial steps of understanding how signaling works with this system anyway. I'm already having a bunch of people ask questions about, compatibility and things like that, which I'm not 100% secure about, so that's why I haven't been answering those, but I am teaching, or at least experiencing what I'm learning as I go along with these videos. So today we're dealing with this unit from Digitrax called TSMK, which is a terminal strip basically. And what that allows me to do is use this terminal to basically screw in the leads from the LEDs rather than having to take the supplied test mast and having to cut it off and then having to solder onto these little soldering plates, which can become tedious. And also, if something goes wrong, then you have to unsolder, and I can see that getting annoying. And I'm actually really happy that I did not go with this method, because even though it's a little cheaper to go like this, I ended up having to reconnect every single wire here at least 4 or 5 times, and I'll explain why in a little while. So as you can see, everything's powered up. Everything is functioning as far as like the lights, and the way I hooked it up right now, just to make sure everything works, is that the TSMK, which I just explained what that is, that the strip here, the terminal strip, is set up with 2 sets of 5 terminals, which I guess translate to the 2 sets of 5 pins that are in here, which also translate to the 10 wires that are coming from the SE8C through the ribbon and into the clip. And what that allows you to do is set up 3 things. It allows you to set up a mast that has 2 heads on it for what they call the A as an apple orientation. And let me show you what that means. On this graph, which this picture, which I seem to be going back to often, that seems to be the best picture in the entire manual because it's very clear. The A orientation is where the train would be coming in this direction. So a single line or main line, and then either continuing single line or diverging. That's why you would need 2 heads. The top head would be the main line head, and the bottom head would be your diverging route. Either way, it could be diverging this way or that way, but the bottom one would indicate that. And then coming from the other side, you have 2 tracks that are joining one. That's why you have 1 individual head for each one of these signals. So the way it's set up right now is, the way this is set up right now, is as if I was setting up this head for the C orientation, which is your sighting. Okay, so if you take a look, and I explained this in video 1, the clip that goes into the pins of the TSMK terminal can be plugged in 2 directions. And I don't want to move this too much because it was hard enough to balance everything out. But basically, if I take the ribbon cable and reverse the orientation to the other way, that would put me into the A orientation, which would be the 2 heads on the one mast. So I would have an extra head on this if I was doing that. And then obviously, instead of having just the 4 wires, meaning the common, and then the green, yellow, and red wires for each one of these lights, I would have I guess 7 wires, 3, and then the other head 3 more. That's 6, and then the commons would all get connected together. From what I understand, I actually haven't tested that out yet, but I think that's the way you set it up. You know, the nice thing about Digitrax and this terminal here is that everything's listed, everything's labeled rather. So you can see it says low, that would be for the low head on the A mast, and high for the high head, meaning the upper head on the bottom here. And then obviously each one of those you can see the labeling. You can see it says common, starting from the bottom up. Common, then red, which is where my red wire is, yellow, green, and then aux, which I have no idea what that's for yet. I'll figure it out later. And then it repeats again over here on this head. So common, red, yellow, green. Now the only thing that I found a little bit tricky when I started wiring my own signal was that they want the common wire, in order to set this up the way, you know, have it working, they want the common wire on the low head side, but then all the lights on the high head side. And I think if you were setting up the other, you know, the B orientation, everything would be backwards, meaning the common, I think, would be on the bottom and the 3 leads would be on the top. I'm not sure. I got to play around with that a little more, but this is the way they wanted it. I thought the common would go on the same terminal as the 3 other wires, but apparently that's not the way it is. And it is working correctly right now, so I just went with that. Now, here's the other thing that's nice about these terminals. They come with the resistors already built in. So as you probably know, these LEDs take very little to fry. So these are rated at like 3 volts or whatever, these little tiny LEDs that I put in here. And I think the board puts out 5 volts, but the resistors bring it down to a manageable voltage. And again, I'm not an electrician. I have no real training in that. I'm just going by what I've learned. It's very minimal, but all I know is that my LEDs are not burning out. So that's nice. Now, the one thing is, when I initially plugged it in with my test unit, with my test signal, what I did is I added a 1K resistor. I have right here. I added this to the common just in case, because I thought it might be I might have burned the lights out if I did not. But I took a risk, you know, that's what I have this for, and I took the resistor out and it worked just fine, and it's working fine now as well. Now the only thing is, I don't know, I mean, I like the light that it's given off, but I might want it to be a little bit more dim. That might be a little too bright for you know, for a realistic kind of feel. But I don't know. I got to put them on the layout and actually see what they're going to look like in place. So that's another nice thing, that I didn't have to, you know, it's going to be a lot of signals eventually, and I don't want to have to put a resistor in every single signal that I put up. So that's a nice little feature. Okay, so that's a terminal strip. Now, here's where I ran into a little bit of a problem when I started plugging everything in. In my head, well, let me start here. When I first tested these signals, I used a little, you know, 3-volt battery, a little watch battery. just to figure out what the polarity, you know, like what the plus and the minus, or the common and the you know, the other leads were. And from what I could see from testing these out, you know, it only worked one way, obviously, and that was with the black wires as the common and the red wire as the lead. So you know, I was getting all the signal from the red wire, but for some reason, when I went to plug it in here, I did that. I put the black wire in the common, all the black wires there, and then the red ones were, you know, accordingly per light, per color, and they turned on. They all turned on, which was what really confused me, because they were turning on, even though the yellow seemed very dim. They all turned on, but the other thing that was happening was that the yellow would stay on, and the other lights were the green and the red were, you know, able to jump back and forth. So right away I saw, you know, I was like, oh, what's wrong? And initially I thought, you know, it was that incident that I had in part 1. And if you don't know what that is, just go back and watch that video. But I had a little snafu in part 1 that freaked me out. So watch that. But it turns out that I guess the cathode and the anode are reversed on these LEDs, or they come, you know, set up where the red is the common and the blacks are the leads for the colors. So once I mean, it took me a while to figure that out, because I was testing everything, every combination and every address from the list here, and I could not figure it out. Everything was going just really, I mean, everything was like, lights were on and things were working, but in the wrong direction. I would try to get a green, and I would get a green and a red like at the same time, or a yellow flashing with the green back and forth. It was just really weird stuff happening. But as soon as I hooked up the right way, it all worked. So I can sleep now. I got it figured out, and I won't be racking my brain trying to figure it out for the rest of the signals. So that's good news. So yeah, once I got that hooked up, then I was like, that opened up a whole set of like options for me, because I do intend on you know, running this system in many different ways. So I do have a CTC panel in the works. I'm working on CATs right now to create a CTC panel, so that I can do like a dispatching situation for, like, you know, for my operations and stuff. But I want this to also be able to work automatically, just switching turnouts, which that I had a little bit more experience with. I was kind of fooling around with it before I went on vacation, and I got to understand it pretty well. And so I had like almost like a dummy panel set up in JMRI, not in CATs, that has some, you know, kind of basic signaling happening with detection, and also with protection, like sensor protection and block protection and things like that, and signal protection. So I want to be able to run it in any situation. But from what I understand, once you have the hardware set up, then the software is what makes your scenario change. So these signals are going to be there no matter what. It's just the way that I'm going to run them that's going to be, the difference. And of course, there's many other things that I'm probably going to have to do to get everything to work, correctly. But if I'm just running trains by myself here, I don't want to have to deal with dispatching myself, meaning, clearing signals manually and all that stuff. So I want to just run trains, and the signals will change automatically, which I guess that would be like ABS, like automatic, signaling, but or whatever that's called. I think it's ABS. I might be wrong with that. But at least I know that I'm probably going to have the options either way. Okay, so let me just show you how this works now. Now we've got to pass all that stuff. First, I'm going to show you with the throttle what I'm doing. So, like I mentioned before in the beginning of the video, we're dealing with the C orientation right here, and we're dealing with code, or rather address 263 and 264 in order to get all the combinations. So red, green, yellow, or flashing yellow. Right? Everything is driver 1 right now that we're dealing with because that's hooked up to driver 1. If I was hooked up to the next one here or that one, it would go down the list: driver 2, driver 3, driver 4, all the way down to 8. Okay, but right now we're only dealing with this top chunk here. So what I'm going to do is I'm going to program 263. I'm going to throw it, and that should give me my red signal. Let's see if that works. So 263 is already there. See, it's closed right now. That's why it's green. Now I'm going to throw it by pressing T, and there it is. So, you know, I already did this in part 1, but I did it with the test mast, which is already wired automatically for me, that thing right there. So I didn't have to worry about, you know, what wire goes in what terminal and all that stuff. So I'll go back and forth again. Here's closed, and here's thrown accordingly. So now the next one would be the yellow lights. So that would be address 264, which will give me the yellow and the flashing yellow, depending on how it's set up, thrown or closed. So let's go to, oh, and by the way, once you hit switch on your throttle, you don't have to hit it again to change address. I learned that, you know, a few hours ago. It's just a lot, you just hit the number, 264, and we're gonna throw and close. So right now it's closed, and we're gonna throw it, and that gets me my solid yellow, and then we're gonna close it, and there's my flashing yellow. So again, solid, flashing, and then I'm just gonna go back to 263 and just get it to red. I like to reset to red. I don't know, I just feel like that's the default color. So there it is. All right, so that's that. So I know that everything's working accordingly, meaning the control board is communicating with the signal correctly, with the right addresses, and all the lights are working. Now, what I did, let me show you the panel on JMRI up here, is I created this test panel, and the signal that we're talking about right now that I'm testing, sorry about the focus, is this signal here, because this whole thing is considered terminal 1, or a driver 1. Okay, so all of these signals are coming out of driver 1. This would be your A orientation, because there's your main line, and you would need an A1 and an A2. That's what these two heads represent. Then here are your two B and C orientations. The B would be the main line, because this turnout goes straight in this direction, and then it turns over here. The C is your diverging, because when you throw this turnout, now you're diverging to the left here, and that's what this signal is here. Now this signal that I'm pointing out right now is the one we have hooked up right now that we're testing. So what I'm going to do is I'm going to throw this turnout, and you're going to see that all the logic that I built into this and I programmed in here is telling this that there's a clear if the train is coming this way, because I'm in the diverging route, so it would go straight that way. I'm sorry, there's a clear here if the train is going in this direction because of the thrown turnout. Now, if it was going in this direction, meaning the opposite direction, it would still be green, because the signal's on the right side of the locomotive, and that would tell the conductor, the engineer, to keep going, and then you would be connecting to the main line. So that's why it's green. So it just went from red to green. Let's see if that's true down at the signal. And if I can find it, oh, there it is. Yep, it's green. Okay, now I'm going to throw it from the computer without showing you the actual computer screen, so you can see this thing change. You'll hear the tortoise machine going. Here it goes. As you can see, it went to red as soon as I switch it. I'll do it 2 more times. Here's this is diverging, and then main line. And again, it's turning red on the main line, when I switch it to mainline, because this signal is considered the diverging route. So it's telling you that the route, I'll show you back up here, is not available. So you would be coming this way on the train, you'd have to stop here because this is not lined up. And then again, once I switch that, it switches over. Now, I did set up the logic, and I can't run it right now because I don't have everything set up correctly, but that'll be the next video probably. I set up the logic so that this train that's waiting here has a green. It would continue. As soon as it would pass this, that one would drop, meaning it would turn red. And then once it got through here and past this, that would turn red, and so on and so forth. The other thing is, though, that when I actually have locomotives running, once they pass through, then all of these go to red, unless I've cleared that route. Because right now it looks silly that there's like a green going in this direction. It's just the logic is giving you all the options right now that you have. It's not acting as like a real situation where, you know, all the signals get knocked down once the locomotive passes and goes to the default, you know, reds. So it's nice to know that everything's working both on the logic with JMRI and also down in the physical world, meaning like the actual turnouts and signals. So I guess the next step now would be to centralize. Well, first I got to figure out where all my signals are going, and if I have room, because the other thing I'm thinking about is, you know, what type of signals, and if I need a bridge or if I need some kind of situation, because, you know, sometimes you don't have room on the actual layout to place a signal. So I'm doing a little investigating as far as, like, you know, how the railroads work when there's no room for the signal to be placed there. And obviously on model railroads, usually things are tighter than the real world. So you have to be really, really careful with how to do those things. So yeah, that's the next thing, to figure out where the signals are actually going to be placed on the railroad, and then just centralizing this particular board somewhere under all of, you know, where there's going to be a lot of signals. This way I don't need to run a lot of long ribbon cables everywhere. But it looks like, if you see my layout, you know that there's a peninsula in the middle. A lot of the signals are going to be going under this peninsula. So I'm probably going to have one board like in the middle of this thing, like under it. And then I think I might have to have one over here. Well, either over here, because there's a lot of crossovers over there, and the same thing on the other side and over here. Or I'm gonna have to, excuse me, I'm gonna have to put it all the way at the back there, where there's that's where my Y is, and that also can run over to that section back there, where I have more crossovers. There's another 2 sets of crossovers back there. So I don't know. I think eventually it's probably gonna have to be 3 or 4 of these to cover all the signaling that I need throughout. But we'll get to that in later videos. So thanks for watching part 2. Again, I hope that this helped all the rookies out there like me. And if you stick with me and you keep doing what I'm working on, then we'll get there together and figure out, you know, all the signaling stuff, which is very appealing to me. I actually really enjoy it. I'm having a blast learning all the computer software and a lot of things that I never even imagined I would do in a layout. So this is a lot of fun so far. All right, thanks for watching part 2. And if you want to see the other videos, just go on my channel, YouTube, in my YouTube channel, Rhythm Railroad, and I'll probably set up a playlist very soon so you can just watch them all back to back. All right, thanks for watching.